Awesome. Hello, everybody. Welcome back to another Logos Bootcamp workshop. This is the penultimate workshop now. So well done, guys, for getting this far along. We have one more tomorrow, this one, and then one more, no, not tomorrow, on Wednesday, sorry. So in 2 days' time. And that's vibe coding session 3. Today, we've got vibe coding session 2 with Backlab, where we're going to sort of be looking at the Logos blockchain, the messaging, and hopefully you can get building a bit more. And I think, yeah, it'll be a couple of demos. Vaclav's going to run through some demo things with his Claude. And as ever, drop any questions in the chat, in the Discord as well. There is one thing to note with certificates. Obviously, you guys are all going to get a certificate with this series. And the way that works is you just need to make sure that your display name is the name that you want to have on your certificate. So you can change that in your account settings on your platform, and then I will get these certificates sent out to you guys once this series concludes. So yeah, I mean, there's more information on that. I just did a little update on the Discord channel, so go and check that out. See what needs to be done. But without further ado, I will hand over to Vaclav, who will kick things off. You're on mute, Vaclav, just by the way.
Once again. Yes, I have a little bit of allergy, so I might mute and unmute if I need to sneeze or something to not like destroy everyone's head or ears. Thanks, Gils. Yeah, let's go. Thanks everyone for joining. I can see some hellos in the chat. It's amazing. Please keep them coming so that we know that you are here. Again, as usual, any questions, I'm here to answer the questions. So I will show stuff, I will explain stuff, but please keep asking questions. We'll see who comes. I think James is gonna be here. So he's gonna answer stuff in chat. I don't know if Guru is coming, but if he is, then he can answer that as well, obviously. And then I'll try to keep an eye on the chat and keep answering. Now, what have I prepared for today? So we have a vibe coding session, and as I said to Gils, it's gonna be a lot of vibe and a little bit of coding and probably a lot of failures, because that's how it goes. Do I need to share my screen, or do people see my screen now?
We can see your screen. We can see it.
Okay.
So
yeah, I hope others can too.
Yeah, let us know in the chat if you can see it.
So what do I want to show today? Because the title was something like build something private. So I have tried to build. I've negotiated with Claude to build an LEZ, Logos Execution Zone program. And if you've been to my Logos blockchain workshop or presentation, we have talked about LEZ. It's one of the zones, one that we are building the way we think a good zone could be built, which allows for public and private transactions. And so I've tried to build something that makes sense to have it private, right? And so that thing is called WhisperWall. James pointed out that there was something like that on Ethereum, which I didn't know. Otherwise, I could have just asked Claude to re-implement it. We can try to do that. So King of Ethereum Hill was apparently something similar. But basically, the idea is that you have this public wall where you can write anything to it as long as you pay more than the person before you. My goal today is, first of all, show you how that works. But second of all, if I can figure out how to run it in Basecamp, which I have a module for it, because the way the framework we have to build LEZ programs allows you to create an FFI or generate an FFI from the LEZ program, and then I can relatively easily wrap it in a module we might be able to have a UI that shows the controls of this program. And what I want to try today is I want to try to deploy the sequencer on a public VM and ask you to download the Basecamp and download the module and try to run it, all of us, against that sequencer so that we can all outbid each other there and have like a one line there stick forever, for as long as I run that VM. But that's a stretch goal, honestly. If I can show you how it works, and it works, I think that's good enough. So no slides today. I don't have slides. I just have repos. And for anyone who has already looked into LEZ and all these things, I'm gonna just paste in. This is the program that I'm gonna go through this. The WhisperWall. This is the framework I've used to build this, and I think that's about it now. I need to check one thing because I asked dual has data sort of I need to check the I'm trying to figure out why it doesn't run in the Basecamp properly. So let me just check. So let me just try this one more time to see if it loads the way it should load. And if it does, then we're all green. If it doesn't, then we at least know it's broken. So this part is broken. So I'm just gonna let Claude figure it out. Yeah. Even with the apps path, it does not load. Okay. Now, let's take a look at what do we have here. So I have mentioned SPEL. SPEL is a framework. If you are from Solana ecosystem, it's similar to Anchor. We even say it here. It's inspired by Anchor. The original main goal of SPEL was to allow you to generate something called IDL. And IDL is a description, basically, of the functions that your program exposes, so that a CLI, a module, a UI, whatever, can take that, load that, and work with it and call your program. And so this is how it started, but then obviously it kind of blew up in my face because I realized I need other things. So we now have SPEL CLI that uses that IDL to generate the CLI dynamically. We have the SPEL client gen that allows you to generate an FFI so that you can call the program from any other language, basically. So you can build a Rust CLI that calls the program. You can build a Basecamp UI module that calls the program. And then we have the core framework itself, basically, with a bunch of macros that allows you that simplify how things are done. There is a PR. I mean, there is a bunch of PRs that my AI agent submitted over the weekend and merged some, which is good. But there is one here, Zero to Hero tutorial and reference. So this is something that still needs to be finished and polished. So like there will be a tutorial and a documentation for all of the SPEL. So now let's simplify our life by just going through an example, right? And so this is kind of an example repository, excuse me. With a relatively simple code. We have the Basecamp modules here. So I'm gonna go into that a little bit later. For now, what we want to check out is the methods. Methods are generally this structure of like methods, guest, and a bunch of other things is how we structure the LEZ programs and how SPEL expects it. And so WhisperWall should be relatively simple and straightforward, like, right? It's 200 lines of code. What does it actually do? So first of all, we have the macro LEZ program, which tells the SPEL, the framework, that, okay, here is the code for the program. Go through it, check all the stuff that is there, and make something else out of it so that we can build it as a guest program, which is a risk zero program. So we need a bunch of instructions. So in LEZ program, instruction is a kind of a callable function. So in Solana, I don't know how it's called, honestly, but in Ethereum, it would be a function of a contract in Solidity, right? So, sorry, I didn't mention that. If you're familiar with Solidity, for example, and you are looking for something like what is the IDL, which is what SPEL generates, it's the ABI generated by Solidity compiler, right? So ABI in Solidity allows you to understand what are the inputs of function calls for a smart contract. And this is basically what we do here. Why did you model the wall as a single PDA-backed state object rather than a split link messages or bits across multiple accounts? I mean, we could. I have just basically wanted to have something simple. And so I think this is a question about this particular one. So the initialized function or instruction has two inputs. One is a state PDA. PDA is a program-derived account. So it's an account that allows to be controlled, that can be controlled by a program that owns it. So it's kind of like a you don't have an actual you don't have actually a private key for that account. It's similar to smart contract in Ethereum, right? Like you don't have a private key for a smart contract in Ethereum, but there is still data stored and there's an execution. Here is different model, so we don't have an execution in that PDA. We don't have any source code, but we have state stored in there. And if we need to, for example, execute something, some modification, it's the program that can do it, that the PDA is derived from. And so here we are using something to generate the seed for the PDA, and we are using literal value, wall underscore v2. For whatever reason, probably Claude had v1 and then just dropped that. It could be also based on a variable, right? So it could be based on the initializer account. So then we could have multiple walls, and you could choose where do you want to write. So if I create a wall, a WhisperWall, then this PDA would be generated from my account submitting the initialize. If then Gil's does the same thing, then he would have a different wall, and people could decide where they want to write to. Here, I just wanted to deploy the program and have a one wall for everybody. That's kind of the point. And I think that answers Humboldt's question, hopefully. Let me know if it doesn't, if the question was different, if I misunderstood. What invariants are most important in WhisperWall and where are they enforced? Macro layer, runtime checks, handler logic. I'm not honestly sure. Invariants as in... okay, sorry. I'm lost in that question. How much of WhisperWall's logic is really app logic and how much is there to demonstrate LEZ privacy payment mechanics? So the privacy side of LEZ is very simple. It's basically just I can submit a transaction privately. So execution of the transaction happens locally on my machine to produce a proof, and that proof is submitted on chain with some encrypted data if there is a kind of a recipient of the data. And so the idea of like the program itself, the WhisperWall program itself, does not really care about privacy. It cares about, okay, I need to store some state. I need to do something. I need to verify that whoever is sending the transaction has signed it in some way, whether it's public or private, doesn't matter, so that the person is authorized to do the thing and that they are actually executing some value transfer that matches the criteria that have been set by the program. But it does not do anything with privacy per se, right? So it's to demonstrate all these things. Like there is not much to the payment logic, payment mechanics in LEZ. It's just the LEZ tokens that you get from the sequencer Pinata default program are just transferred here. As simple as that. There is nothing complex about that. And from the perspective of privacy, yes, we are demonstrating that we can do private transactions, but there is nothing in the program itself that would actually allow that. That is allowed by the tooling around and by LEZ itself, but the program is very minimal and very default and will work the same way whether you do it privately or publicly. What metadata still leaks in the private path even when signer identity is hidden? Well, depends on how you design the program. Here, everything is public apart from who submitted the transaction, right? So if I am writing on a wall, nobody knows that I have written on the wall, but everything that is there, so how much did I pay and what is the written on the wall is completely public. And that can be like, depends on how you design your program. The team is currently working on private PDAs, which will allow you to store private state rather than here, because the PDA is a public account stored on chain, the state is public, but I don't know who edited the state based on the transaction submission. Out of interest, what were the hardest edge cases in deriving accounts and PDA seeds automatically from instruction definition? Honestly, I have not written a line of code for that. It was all written by AI and then fixed by other people where it was broken. I don't think it's complex. I'm not 100% sure how clean the code is because I'm not a Rust expert. So if you are a Rust expert and you go into SPEL and you hate it, then please tell me or tell us, and or even just go and fix it if you want. So the code might be terrible. But the idea was that we now can have kind of idiomatic ways of how to derive these seeds for PDAs. Honestly, edge cases, everything should be tested, and we have a bunch of ways to derive the seed from like multiple paths, let's say. So we have literal, which basically takes that string. We have account, so the account you pass into the program execution, they can be used to derive a seed. We have arguments, so you can derive you can co-derive the seed from the argument, and you can combine these, right? So you can have like a literal and account and an argument passed in, and it seems to work because I'm using all of the combination in LEZ multisig, which is LEZ multisig, which is the which is in a multisig implementation that I have basically used to build SPEL and test and understand how LEZ works. And this basically uses all of these combinations, so that, I mean, most of the stuff that I've developed in SPEL initially was to support the LEZ multisig, and now people started adding other things that they need. Okay, let's move on. So we have this state PDA. So this will contain, again, the wall, what's written on the wall, some statistics like how many rewrites there were and how much tokens have been collected, and what is the latest tip that has been or bit that has been used to rewrite the wall. And then we have the signer. So the admin has some privileges, like draining the treasury or whatever we want to call it, draining the account, or clearing the wall. Obviously, if it was supposed to be completely decentralized and whatnot, the account wouldn't be there. And then the account is also public. I think I wasn't really worried about making the admin private. And I haven't tried. So when we initialize, we create the initial whisper state. So we record the admin. We initialize the latest whisper and zero out how many whispers there were, total tips, and the last tip. And we serialize it into the state account data. And then we pass it back out to SPEL, which then does some magic so that it's properly verified, authorized, and everything for the LEZ program execution. The second instruction then is whisper. I don't think that this is actually needed. I think Claude did it initially, and then we added the tips, and so he kept it there. But basically, this is like if there is if it's fresh, if it's freshly initialized, the the first whisper is free. And so we again pass in the PDA, the state PDA, and we pass in the signer and then the message. And so the signer, the account type signer, verifies that the signer actually signed, or that the commitment is valid. So like if it's executed locally for privacy, everything is verified. If it's executed publicly on chain in the sequencer, then everything is verified that way as well. We take the data from the state, we update it with the new message. We make sure that here we make sure that the WhisperWall is actually empty, and if it's not empty, we error out, and then we update the latest whisper, and we update the whisper count with +1, and then we go and store the data, and then we again return all the accounts that we got back in. And if there are any chain calls, which here are not, we would have the chain calls there. A chain call is basically a way for the program to call other programs, and you can construct them similarly to transactions, and then they can basically do essentially anything, and they can be multiple of them, chaining them and doing really fun stuff. Now, this is the more fun part where you can like override existing whisper. And this actually does a chain call, so we'll look into that. And so the signature is just slightly different. So we have the state account, we have the signer, whoever is actually submitting, we have the message, and we have the tip. And basically we do the same stuff again. Instead of checking whether it's empty, we check that the tip is lower. Oh, yeah, we error out if the tip is lower than the last tip. Sorry, yeah. So we check that the tip is bigger. This is a weird syntax, not syntax, weird way to check this. But it's to not having to not have to else and things like that. Anyway, we check that the current tip is not smaller than the last tip, and then we, if that passes, we update the last tip, we update the message, we update the whisper count, and we update the total tips. We serialize that, we put it in the state, and here we build the chain call. So we need to create a chain call that goes to authenticated transfer program, which allows us to do private token transfers. And it has to have this instruction data, which is basically just telling it the balance change. So basically, whoever is signing this detract the tip from their balance and add it to whoever is the second account. So for pre-states, we are passing in the signer clone, and for the state clone. So this is the sender and this is the recipient, and then no PDA seeds because the signer is an actual account and not PDA. And then we pass it all back with the chained call structure in this other vector. And this will allow basically us to update the current state and then execute the transfer. And because this is all atomic, if this fails as well. So if the chained call fails, the actual modifications are not persisted either. And then we have some admin-only instructions. So drain the jar. We're basically saying, well, if the signer is admin, and because it's specified as signer, it has to be authorized, so it has to be signed, so it's provably the admin. Move the balance. So we have basically we use the recipient and we move the balance to the recipient, and then reveal returns the state of the wallet, so we can actually go and fetch the information from the wall. Okay, no new questions. So either everyone left or it's still going. So let's check one thing. Let's check if Claude actually figured out. Okay, it seems that we had a bug in there, which is why it was not building. Just build it. And what we'll do now is we will try to run this. Still listening. Same here. Great. Thank you. Thank you for the feedback. We will try to run this. So we have everything should be documented here. If you go to the README, you should be able to follow this. So we have a bunch of prerequisites. Obviously, I've already went through them. So we have logos scaffold binary, we have SPEL binary, and we have risk0 toolchain if we want to build the program, and Docker or Podman if we want to, which is needed to build the risk0 guest binary for to deploy to sequencer. So you can try that at home, all of that. One thing I would probably say you could do is if you go here to the WhisperWall, and if you install Logos Scaffold and SPEL, that actually might be useful. I'm thinking, well, we'll see. If you want to get it running, get it installed now, it might be useful because we then can try some things together if we have enough time and if it actually works. Because I would like to go through the step of deploying the sequencer to a public VM and then all of us configuring that sequencer and trying to write to the wall and see some rewrites and things like that. We'll see if we get there. So I've already done this. So Logos Scaffold setup, which basically gives me the sequencer and the wallet and all these things. And then Scaffold local net start, which I have already run as well. So I have a running sequencer here. This is still building. And so I can do stuff now, right? I can take this and I can say, this is where my wallet folder will be. And if then we list it, I think I've already done that. So I should have some data in there. There are some JSONs which basically are storing the data for the wallets. I'm not going to stop it right now, but we can check. There is also logs. And so you can see that the sequencer is running and I was doing stuff to it. So there would be, if we saw more, we would see that there are some transactions that have already happened. And so this is how you create new accounts. So you say wallet account public, wallet account new public, and it gives you a bunch of information. And you can take the account ID and then run LGS is the Logos Scaffold command, shorthand. And so you can top up an account. So if we go and let's say we take Bob has balance 50 here. And so if we want to give Bob more money, we can just run this. Oops. And it will execute wallet pinata claim, which is a default program on the sequencer that allows you to mint some test tokens into the given account. And it takes a bit of time because it's actually doing the mining in a sense. It's solving some challenge, and it also is waiting for the transaction to succeed. So if we do LGS local net logs, local net what? Oh, I'm not in the right directory. Wallet top up complete. So we can go. We can do the logs here. We can see that there was a transaction included in the block, and so if we want to check how much do they have, we can go again to get account, and we can see that the balance went up from 150 to 300. And so then we would go and we would build, we would make IDL. So we can run the make IDL for it. The IDL is the JSON format. So if I go now and I open it in the in something that is more readable, maybe not. Let me make it bigger. So this is how the IDL looks like. And so you can see the instructions here. So we have instruction initialize, instruction whisper, and then you can see that each instruction has some accounts as inputs and some arguments as inputs. So here we don't have any arguments, but if we go to the override that we looked at a little bit before, so we have state is the PDA, and here we know how to get the seeds. We have the signer account, which is the whoever is executing, and then we have the arguments, which is message string, and we have tip as a unsigned int 128. And so this is basically what allows us to do things like SPEL. If you run SPEL binary that I have installed as well, we can see that we are in the WhisperWall project, and we have these commands. We have inspect, which gives us the program ID, and we have generate IDL, so we can generate IDL from here. We can print the IDL, so SPEL IDL should print the JSON file. But what's more interesting, we can actually run initialize, whisper, override, drain, and reveal directly from this program, from this CLI. And so this allows us to, this is completely dynamically generated based on that IDL. So it allows us to do stuff without actually building any CLIs themselves. And so if you look here into the examples in the WhisperWall, we have two files here, generate IDL. And so you could just use Rust to build a generate IDL CLI, and that would just call out to the SPEL framework. Or you can have a WhisperWall CLI that will only have stuff that is based on the IDL that is for the WhisperWall, and it just calls out to SPEL run. And so that allows you to have a project-specific CLI, which basically behaves the same way as the SPEL. And so we can try SPEL reveal. The SPEL reveal is strange because it's executing transaction, but there is no point in executing transaction if we have the state PDA. But never mind. We can directly inspect actually the PDA because it's local to us, or it can be pulled because it's public. It can be pulled easily from the sequencer, and that would be this basically. So we can run SPEL PDA state. So the PDA is called state. Yeah, it's included in the blog, but it doesn't really give us anything. This one is weird. But let's try this. So SPEL PDA state. What does it do? PDA gives us a seed based on the IDL for the state PDA. And if the PDA was called differently, we would get a different one, right? So this is the PDA, and then we can, oops, where am I here? And then we can inspect it. So we can do SPEL inspect. I'm just gonna copy it all. We can do SPEL inspect, and we can put this here. And so what this does is that it takes that seed, it derives the account from it, the PDA, and then it uses the type, the Rust type that you have defined and annotated, to decode whatever is in the data. And so we can see that there was latest whisper was louder, and whisper count was 2, and the tip is 1, and who is the admin. And so if we look into actually, how do we do that? Can we do that? If we go with wallet account get account ID, I'm thinking we use this public. So this is the data, this is the data that is being decoded, right? And we can see it here. So it fetches this information and it looks at the data, and then based on this type, whisper state, it decodes it. And it allows you to easily check whether whatever you're doing is working, or to display it somehow, right? In a given in a given UI or TUI or whatever. So I'm just going to try to run this command. So I'm going to launch Basecamp. I am going to install a WhisperWall module. Sorry, not here. Here. Install LGX module. Oh, sorry, this is too small probably for you to see clearly, but that's just my resolution getting in the way of demoing these things. It is asking me to whether I want to upgrade the package, and I say upgrade. I'm going to unload the package. I'm going to load the package, and it's not going to work again. So yeah, this doesn't really look like it's going to work. But what we can do, we can still stay in the command line, and we could try to use SPEL quickly to submit, so overwrite a whisper. So I'm going to use SPEL overwrite message will be hello encode, and tip will be 2 because I think the last tip was 1, and the signer will be, who's gonna be signer? I think here in the README there was a bunch of them that I generated, so I can do Carol probably. Inspect, override. Yeah, I can do Carol. So we're gonna try if Carol has any tokens, and so we're trying to submit it now into the sequencer locally running, and we'll see if that works. I'm going to take a look at the chat. What did building WhisperWall reveal that forced changes or improvements to SPEL itself? Well, very good question. Thank you for that. It revealed that the FFI code generation was broken on multiple places. So there is, transaction is confirmed. So there is a document here. It's not the document. Where is it? There is a document somewhere here. Notes. Yeah. So here in the notes, there was a bunch of issues filed during the development. Some dependency, generate IDL didn't do stuff properly for some edge cases. SPEL re-exports. So we needed to bring in the whole LEZ repo basically as a dependency, as a separate dependency of WhisperWall, but we could actually do that as a as re-exporting. And then there was something else. There was a few other things that were submitted, but this may not be completely updated. But basically, a few things around the code generation as well. So if we look here at the pull request, there are still some opens. The re-export errors didn't propagate properly, and the generation of account down with PDAs did not really work properly as well either. So there was some fixes. There are some workarounds in this code that wouldn't be unnecessary if this was fixed before. So we can quickly go and check the, where is it? Here, logs. We should see that here there was a transaction executed. That's the one that we have done, and we can inspect the PDA and we can see that there is now total tips free. So the previous one was 1, and now we have added 2. So that's 3 coins. We had 3 Whisper counts in total, and the latest Whisper is hello encode. There was one more question, I think. How do you think about replay resistance, non-handling in private transaction flow? So this is solved in LEZ by basically publishing a nullifier that prevents the replay. So when you generate the transaction, you submit a commitment, and then you submit when the transaction actually is like settled, there is a nullifier submitted to the chain. So there is this combination of 2 things: commitment and the nullifier for that commitment, so that the transaction cannot be replayed in the future. Oops. Okay, so let's check if we have a how-to for the private transaction, because I was doing it before, but I don't know if it got written here. Private run, yes. Okay, so we need to do, if we want to do a private transaction for the accounts, we need to run sync private in a sense periodically before every transaction, because we need to make sure that our private accounts are properly working. We need to know the binary, which is, so this is the authenticated transfer binary that you saw in the in the code that is being used as a chain call. So we need that. Oops. So we need the path of the binary. We need a private account. I am not sure if this is actually a real account. Let me check. Wallet account list. We don't have this one in particular, so we might want to create a new one. So let's try new private. Is it like that? Yep. So now we have a new private account, and let's do the sync again. We need to fund it, so let's call top up again on this one. It's running the out transfer init, which basically makes sure that this account is owned by out transfer, so that out transfer can do the balance editing basically. And so once we have that, we need this. So we need to set the out transfer binary path, because it needs it when we are doing the private transaction. It's executed locally, and then just the commitment and some data is submitted on chain. And so we need the path to the binary so that it can actually properly locally execute it. And then we call the override signer standard stuff basically as before. The one caveat is that doing a private transaction takes quite a long time. Right now, it's going to get better in the future, but since you are doing all the proving and calculations locally, it just takes time. It can take minutes, basically. So we will have to wait a bit for that. And in the meantime, still does not upload. In the meantime, has anyone, show of hands in the chat, please, if you have Logos Scaffold and SPEL installed? If anyone has done that. Because if so, then I might be interested in going and deploying the sequencer to a public VM, sending a link, and then we could all work against a single sequencer. And if we do that, then we might be able to try to submit something to the wall, to the single wall, basically, more of us, not just me playing here on my laptop locally. So, but you need to have the scaffold or at least the wallet, ideally both. But if you have not started the SPEL installation and scaffold installation before, it's cloning a lot of stuff. It's cloning a lot of stuff and building some Rust and stuff like that. So it can take a while. That's okay. I think so someone says, Stefan says, LGS says project WhisperWall is not Logos Scaffold project. That's okay, because I think you need to run Logos Scaffold init in the folder, and that's missing there. The reason for that is that, or the difference between you and me here, is that I have this file, scaffold tunnel, which tells me like some of the versions and some of the URLs and things like that. And so I did not pin it, because then it would have this cache root. So I didn't want to push it because it would have this cache root and potentially some other things that are not really meant to be generalized. So I think that if you just run LGS init, it will generate this for you and build a bunch of things there, build the sequencer or get the sequencer and things like that. Okay. So this is actually still going because we are doing the private claim, and that just takes a long time. Okay, perfect. Stefan says that it's working now. I'm gonna try this one last time, and then I'm gonna get to setting up the sequencer quickly. Great. Yes, so now it works. Again, I'm sorry for the size of the text, but you can see that the Basecamp UI now shows hello encode, and that there are 2 tokens, very tiny stuff. And I could probably figure out if I have the account. One of the accounts should be able to. Let's try this. Override. So mine is better, and I'm gonna tip 5. And if I try to override when the transaction gets included, so there was something green, which was like a success submitting transaction. Here we have the transaction information, and now it's overwritten with mine is better and 5 tokens. So this UI would allow us to write, or allows us to write to the wall directly from the Logos app. And this is something we didn't go through, but basically we have a generated FFI for from the program with some tweaks, sadly, that we had to do because SPEL is broken slightly. But it allows us to basically interact with the program from the QML plugin, and then this is the QML, the UI that you saw there, and then we have this WhisperWall core, which is what which is a state. I'm not even sure this is. I think this is not necessary. We need to remove that. There's some leftover. Anyway, let's see if that actually finished. No, it's still doing that. So we have 10 minutes. So two options. Does anyone actually have the SPEL and logo scaffold apart from Stefan? Stefan? I don't know. Sorry. I don't know your language of was the mother tongue. So I pronounce your name correctly. So we can either talk about stuff more and answer questions, or I can try to set up the sequencer on the VM. Okay, so this succeeded. Okay, so we can try to submit the private transaction very quickly. So we want to try to test wallet account get account ID. Yeah, so we have this private account funded with 150, and so SPEL override and signer will be this guy, and we will do hello encode but private. We need to give more. Let's do 10, and we need to provide the oops that's not going to work. Bin out transfer out bin, I think it was. Yep. Out. Out. So this may actually work, and this may actually use a private transaction and override the wall on the message. Autofilled program ID. Yeah, it looks fine. So okay, so I have this VM here. So let me try to quickly clone. I don't know if that makes even sense to try, because to be fair, I'm not even sure if I have Rust here. Git clone. I might not even have this there. Okay. Yeah, I think that was a bit naive because it took me too long to explain everything. So we may just want to try to wait for this transaction to go through, if it actually does. You can see that my laptop is working hard. Load is 24, and it's all the RISC-0 VM calculating the proof for the program execution. And so this is going to take a bit. So I think in the meantime, any more questions? Oh, there are. Trying to work my way through the README, but won't make it in the minutes. Yeah, I understand. I mean, I think it would be super cool if you guys, on your own pace at home or wherever, if you install the scaffold, I'm gonna take the remaining time to paste the links again. So if you go over this at your own leisure, and then let me know, I'm gonna create a thread in probably in Logos Discord, and I'm gonna paste the link into the Encode Discord. So if you go through the README, and if you try to write something to the wall, and you are done with that, if you're done with the README, if you find issues, please submit issues or ping me. I'm gonna fix it. Like the init step, please, Stefan, if you can submit a pull request, or at least write it in the issue so that I don't forget. That would be great. And as you get to the point where you are like, okay, I know that I can replicate this, let me know in that thread that I'm going to create, and paste into the encode Discord. And then in the meantime, I'm going to set up the public sequencer, and then we can try the WhisperWall together, right? We can try to override stuff and have some fun with that. I think that would be pretty cool. And yeah, but obviously probably we won't have time to do it right now here. So I would rather probably answer more questions if you have any. Missing a easy. Oh, setup, right. Okay, I'll have a go at it tomorrow. Perfect. Yeah, I'll post it right after, and I will keep an eye on that for the next couple of days and see if we can get something fun going there. Again, any more questions? Definitely go check buildlogos.co. So check the Builder Hub, check the Basecamp, Gurus. Check the Gurus workshop from last week about how to build in Basecamp. We got it working too. I mean, Claude did. I didn't do much. I was just bitching about, hey, it doesn't work, it doesn't work, it doesn't work. And we'll see. This may or may not succeed in next 2 minutes. So we may or may not see a private transaction passing. This is one issue with the private transactions, and the team is also like working on that and looking into how they can optimize this. It just takes a lot of time on a reasonably beefy machine to produce a private transaction, but that's just because the zero knowledge proofing of the RISC zero VM is just that slow, sadly. And that's why there are projects out there trying to do like a marketplace for zero knowledge proving and things like that. So you leak data to them, but you don't leak data to everyone publicly and things like that. But we just need to optimize these things, I think. That will be probably the path forward. Okay. Any more questions in the chat? Where can I find other workshops? You can find them in the Encode Club program. Since you are here, you're signed up to this Logos Privacy Builders Bootcamp, and there is a list of all the workshops. And then if you click on that workshop, it will allow you to watch a recording. And I think it's also available on Encode YouTube. And we will probably do similar stuff on our socials, like logos_network on X and elsewhere, YouTube as well. So you can catch the next iterations there as well.
Okay, awesome. I might have to jump in here, Vaclav, because we've got another workshop being hosted. But thank you very much for hosting that one today, Vaclav. And for everyone who is listening here, we have the final one is tomorrow. It's at 4 p.m. BST, so that's UK time. I'll send a reminder again on Discord about that. Sorry, it's not tomorrow, it's Wednesday. My fault. It's on Wednesday, so 2 days' time. For those who didn't catch earlier, make sure your name is updated on your platform page so that I can send out your certificates at the end of this, and it will have the correct name on it. There's more information about this on the Discord. I just sent a message earlier. So yeah, same name that you want on your certificate on your display name on your platform. And yeah, as Vaclav mentioned, all the catch-up recordings are available on the platform. And yeah, awesome. Thank you very much for Vaclav, and I will see you guys again all on Wednesday. Perfect. Thank you, guys. Bye, guys.
Thank you, everyone.